Okay, so yesterday's lesson, you went over adding and subtracting polynomials. So let's just do one of those just to see how our skills are doing. And go ahead and try to solve this. I got the weird marker on. Let's switch it up. And take your time with this one. First of all, the first thing you need to look at is changing this to a positive, but flipping everything in here. All of this gets flipped, okay? So then from there, I want you to 5x squared. Well, let's just take a look at our degrees. What are our degrees? Our exponents. So this is negative 3x to the fourth. Then I have 2x or x squared and x squared. And then I have x's. So we're going to organize our work. Negative 3x to the fourth. And then I have 5x squared and positive 2x squared. And then I have 4x and negative 8x. Remember, that's a negative 8. So that's going to be negative 4x. Just make sure my work is clean. Did I mess anything up? No, we're good to go. Okay, so now today's lesson, or today's EDPUZZLE, is going to deal with what we reviewed on the last day before break, and that's multiplying. Yesterday we did adding and subtracting polynomials. Today we're going to be multiplying polynomials, okay? First step. Let me go ahead and show you what it looks like. If I gave you, we're going to start with just doing two binomials. My computer acting up. It's okay. So now, when we deal with this, if you remember, I wanted you to create a square, and we're going to organize our work that way. Let's just talk about what's going on here. What is the main concept? Imagine this. Imagine you are crossing this 3 out, and you're just distributing the 5 into this. Okay. Simple distribution. You get what? 10x squared minus 25x. And then imagine the same process. You cross this out and you distribute this 3 into parentheses. And you get 6x and negative 15. That's exactly what you're doing, but for the method I give you, it helps you just organize your work a little better. And some people remember when they were even taught, I think, multiplication, I think you guys mentioned, the lattice method. There's a couple different ways. So when you set your work like this, then I'm going to go ahead and put the terms. So I'm going to put 5x here and 3. Make sure you set your terms up properly. It doesn't matter if you put 2x minus 5 down here. You just have to keep that all together. You can't put 2x and then all of a sudden a 3 or something. You got to keep that binomial together. So it doesn't matter which way your binomials go, but they have to go together still. Don't forget, I put negative 5 here. You guys see that? Negative 5, okay? You don't just put 5. That's not just a 5. That's a negative 5. And now, when you look at it, you're only caring about one box at a time. You don't even look at any of these other boxes. You don't even care about any of this. All you're worried about is that 5x and then 2x. So when you do the 5x and the 2x, you're going to multiply those together and you're going to get 10x squared. So when I do this, 10x squared goes in there. And then I'm going to do the next multiplication, which is going to be right here. And that box is going to be 5x and negative 5. Do you see how I'm doing this? Okay. And that's going to be negative 25x. Okay. Then I'm going to do 2x and 3. And I'm going to get 6x. And then negative 5 and 3. I'm going to get negative 15. And what I told you guys to do initially was to write it all out. So 10x squared minus 25x plus 6x minus 15. If I write that all together, then I look at it and say, this is like yesterday's lesson. I look at all this, is it done, or can I Can it combine anything? Is there anything in here I can combine? You know I can combine those two terms. All right, so your final answer is 10x squared negative 19x minus 15. Okay. Pretty easy. We're going to do a couple more and then spice it up just a little bit. But it's not too tough. I'm just reviewing this for this week. This week is a very kind of basic, simple week to get you started, get you into school, into math frame of mind here. All right, next question. Let's do... All right, go ahead and solve this one for me. Set up my work. 6x squared, 3x, negative 16x, negative 8. Write it all out. You'll start to realize that the same common spots are your like terms on these kinds of problems. They're not always going to be that way. You can tell those two are like terms. So your final answer is 6x squared minus 13x minus 8. Okay. Not too tough, but now let's go into something a little more challenging. So when you have to deal with a binomial times a binomial, I feel pretty comfortable you guys can handle that. Now, what happens if it's a binomial times a trinomial? Okay, those times are going to happen. They could give you any kind of term here. 3x plus 5, and now look what I'm going to do. 2x squared plus 4x minus 3. All right? Now looking at this set of expressions here, these two expressions, you're still going to set up a model, an area model, basically what you're going to look at. But instead of this being a simple, you know, two terms here, two terms here, you notice it can't be two terms and two terms. One is two terms right here, but then one is three terms. So your square, your rectangle, whatever you're using, is going to have to get a little bit larger. You could do it either way. You could do it this way, where you have your two terms are going to be up top, here and here, and then your other terms can be here, here, and here. Or you can set it down if you'd like, and that's what I'm going to do. I like to do it that way. It just looks a little better to the eye to me. When I set up my little area model here, it doesn't have to quite be that big, but notice that I have two spots over here for my 3x and my 5. And then I'm going to go ahead and put 2x squared, 4x, and negative 3. Same concept, just looks slightly different. And then I'm just using different colors so you can see my work a little better. But remember, this is going to be 6x to the third, right? Because there's an x and that 1. Remember, you add exponents when you multiply. Same bases, you add exponents. Okay, that's going to be 12x squared, and that's going to be negative 9x. Down here, it's going to be 10x squared, 20x, and negative 15. So this time, I'm not going to write them all out because I want you to see just visually where are your like terms. If I chose to, using the highlighter here, let me use a little better of a highlighter. There we go. If I was to highlight, do you guys see these terms right here? Aren't these alike? Okay, those are alike. And then what if I did this term here? And those terms are alike as well. Okay. The other terms on the corners are not alike. So again, you're using kind of this diagonal way of looking at this. This is alike, and these are alike. So write out your answer. I'm going to have 6x to the third. I'm going to have plus, what is that, 22x squared, still positives, plus 11x, because we're subtracting, minus 15. Okay. Let's check my work. Yeah, we're good to go. So let's go ahead and do a couple more on your own. All right, let's try one here. Now my binomial isn't always going to be so nice and clean. Look at this one. Ooh. So when I look at this binomial, I notice that I have an x here with nothing. I have just an integer here with no variable. I have an x squared here and I have an x squared here. Doing this problem is a little more challenging. We're stepping it up a little bit. You're going to, again, something like this, right? And then let me just lower this a little. And I'm going to put 4x squared. Okay. And then as I fill these in, again, remember, like your exponent rules are super important. You can tell, right? So this is going to be 12 x to the 4th. Do you see that? Remember, same bases. They're both the same base. You add exponents when you are multiplying those big numbers at 4 and 3. Okay? So that is super important in algebra. You got to get the hang of that. 20x squared, right? Negative 20, 4 times negative 5. Negative 3x times 3x is going to be negative 9x, but hold up, make sure you add the exponents properly. That's a 3. And then this is going to be positive 15x. Are we good? So what do you notice about my answer? What's interesting? There is no terms to combine. There is no like terms, which is interesting to me, okay? No like terms whatsoever to speak of. All right, so this one was a little more challenging, a little more intense, but you can handle these. I know you can. All right, let's just do one more basic one that you have, that you're gonna have in your work in the future. Let me just give you, this is a very common type of problem. 2x plus 4, 3x minus 5. Now, on your homework from the quizzes, there was like a sidewalk question where it had like one rectangle and another rectangle. And it gave you the area of the big rectangle and it gave you the area of the small rectangle. And it wanted to know this, it said the sidewalk, it wanted to know the space in between those two rectangles, which meant you need to take the big rectangle minus the little rectangle. And that was your answer. This one's not going to be like that. It's not going to be, those are perimeter type questions. This one wants to know, what is the area? What's the area inside here? What is the area going to be? So you got to give me what is going to be the amount of space in here. Okay. Go ahead and try that on your own. If you're lost, you are just going to go, how do you find area? Equals base times height. All right. Whatever way you can look at the base and height, if you wanted to tip this over here this way, then it would be 3x minus 5 is the base, 2x plus 4 is the height. But you're just multiplying your length times your width. That could also be another way to look at it, right? So let's go ahead and set it up. 3x negative 5. 2x positive 4. Make it 6x squared. 12x. Negative 10x. Negative 20. Don't forget you have to combine those like terms. Oops, that's a positive 2x. All right, almost got myself there. And then your answer is this trinomial. Now remember, these trinomials, when we're graphing them in the future, they end up going up to the sky. Okay, happy faces. What did we graph before? We were graphing linear straight line equations. These are going to be called quadratic equations, and we'll talk more about them in the future. Don't even worry about that, but just know that these trinomials, anything with the squared, is very important. That's what we're jumping into the next level. All right, you guys, do great. Have a great weekend. Get this done. I'll see you guys on Tuesday.